This video, we're going to demonstrate using packet tracer for the second exercise is for VLAN, inter-VLAN routing. And this is the topology already created. You can download this one, open it with packet tracer, and follow the document of VLAN routing. So this is the document. The purpose of the lab activity is for a student to use the virtual image to ping the ASA 5505, same thing, like the router on a stick exercise, to ping the 5505 10.10.10.10 address using the inter-VLAN routing. So in here, the student virtual image is exactly the same configuration as the previous router on a stick exercise. Your default gateway to 192.168.11.1. And now this time, we remove the router and configure the same IP address into the switch. Make it a VLAN 11 with 192.168.11.1. And we assign VLAN 1 of this particular router switch with 10.10.10.1. And of course, I change it to different model, so you get you get a chance to look at the syntax of different model of the Cisco switch. And then, so in this case, if the 192.168.11.11 want to ping the 10.10.10.10, the packet will travel here. It's a VLAN 1. And then inside here, inside the VLAN, between VLAN 11 and VLAN 12, it's going to switch over to VLAN 1 and go out to send it to the 10.10.10. And the route add command for this one, we're going to use the route add this time because the switch, Cisco switch, anything below 4,000 model doesn't support NET or PAT. So the packet going out of this VLAN 1, it will carry the source address of the 192.168.11.11 instead of being padded by the router in our previous exercise as the 10.10.10.1 address. So therefore, this ASA, it has to know how to get to the 192.168.11.11 network in order for the packet to be, the ICMP packet to be forwarded back. This is the review of what we have done before so many times. So let's take a look at the syntax. It's pretty similar. Config T, VTP mode server, and you give it the name, give it a password. And now instead of GI, it's fast Ethernet, first port instead of 001. It's actually 01. The first port, we use it as VLAN 1. The 11th port, we make it VLAN 11. And second port, we make it a trunk port and make it allow all of them to go in. So very similar syntax with a slight difference of the interface name. And VLAN 1 this time, this is new. We have to give it a interface VLAN 1, give it an IP address now. And then VLAN 11, we give it an IP address. And we also give a default gateway to the 10.10.10.10. Very important thing is the last line, IP routing. You have to put this command in so that the inter-VLAN, they will be able to route. All right. And then the ASA is the same command. We just configure it to 10.10.10.10 and tell them it's inside security is 100, outside DHCP. And all these ports, I deleted a few lines to make it shorter. We are not going to use that many ports. It's actually from port 0 to port 7. All we're going to use is port number 1 or port number 2. Depends on how you want to connect it. I connect it to port number 1. So those are the same syntax. Now it's also the same. Command and testing result. We use the image to ping the 10.10.10.1. The default gateway is successful, but when you ping 10.10.10.10, it will have a problem because as we already discussed, it doesn't know how to get to the 11. Therefore, we have to say config T in the ASA and the CNASM ASA and say, hey, route inside. If you want to go to the route 192.168.11.0, for the whole class C, you can go to 10.10.10.1. So it's telling the routers a route inside. This is the inside, 10.10.10.10. So inside, if you want to go to 192.168.11 class C network, send it to 10.10.10.1. You just, again, send it to the network that you know how to get there, which 10.10.10.1, VLAN 1 is where you connect it to. So you tell them, you tell your ASA, the CNASM ASA, and say, hey, if you want to go to 192.168.11.0/24, send it to 10.10.10.1. Now, that will complete this exercise. And I have an optional exercise for you to do, and I put it in here. Optional exercise for you to complete for route summarization. Create port 12, VLAN 12, and port 13, VLAN 13. You already have the syntax there, how to create it. So you just add, go to the port number 12 and tell them it's a VLAN 12. And then add the student switch, of course. And then you assign the IP, VLAN IP, to 192.168.12.1 and 13.1. And after that, you're going to add a PC 12 and PC to VLAN 12. And the PC 13, you add it to VLAN 13, port number 13, you connect the cable to it. And then you give it an IP of 192.168. Instead of 11.11, that's VLAN 11, right? I just choose 12.12. And then VLAN 13, use 13.13 accordingly. And then without further configuration for any router or firewall, anything, your PC 12 and PC 13 already can reach 10.10.10.1, okay? 10.10.10.1 is already routable because it's within your inter VLAN. And the 10.10.10.10 is outside the switch. So therefore, the 10.10.10.10, it doesn't know how to get to the new network that you created. So we have to add a route. But we're not going to just keep adding those routes. We're going to summarize it. So we say, hey, 192.168 for the whole class B, anything 192.168.0.1.2.3, all this class C network, we're going to send it to 10.10.10.0. So this is what ISP did to do the route aggregation, or we call it route summarization. And it also reiterate that we covered the concept of, for a large corporation, static route is going to be so complex that it's hard to maintain. Yes, if we use router, it will be. If we have, see, we just created VLAN 12, VLAN 13, VLAN 14. You can create all the way to VLAN 100 or whatever, as long as you stack up the ports, the switch, and you will have the 3-layer switch design, core switch, distribution, access switch. You can have many computers, thousands of computers, hundreds of the VLANs, and then it's all within the VLAN fabric. With, of course, the newest Cisco device, you will use a similar thing as the centrally managed software, like SDN, software-defined network, to make the routing decision. It's similar concept as the VLAN routing inside. The VLAN in here, then they already know how to route and forward the packet. So you don't have to add any static route. The only thing you may want to add is that, hey, when it's out of your switch fabric here in the outside ASA, then you have to tell the ASA where are all those inside network is. So therefore, it creates a concept that you have to use contiguous network, meaning that it's a continuous network. You cannot have 192.168.1.2.3.4 created here, and then you jump it to 172.16, and then you jump it to 192.168.200. So if it's not continuously there, you cannot summarize it. Then your ASA or your upstream routers, their route summarization is going to grow bigger. If you use continuous network, the whole class B summarized with a /16 with the 192.168.0.0, like the one that I show you at the end of the document, then you only need one line at the border device or upstream router. One line, it will be able to forward all the packet to your VLAN fabric, and then they will do their internal routing, and you don't have to worry about any static routing at all. And so that's a reconfirmation and reiterate of what we have been discussed. If you have multiple upstream ASA, you have two ASA here, and create another ASA connected here, and say, hey, all the VPN will go through there. Then you will in your switch say, hey, which VPN you're going to have one line at a static route here. You go here, only one line. You can set all the VPNs go to the new ASA. Otherwise, or else it will default gateway to the traditional ASA to the internet. And all of your VLAN, it will be default gateway to your VLAN fabric switch. So that takes care of enterprise network design. So that's a discussion, and now we are going to do the hands-on to just verify that we can actually configure a VLAN 11, and it's going to be inter the VLAN 11 and the VLAN 1 to do routing. If you can do it inter VLAN 11 to VLAN 1 routing, you can do VLAN 12, 13, 14. You can do exactly what I just described, hundreds of VLAN if you have that many ports and that kind of setup and that kind of design. Okay, so it's kind of integrated together with the previous static routing exercises. All right. Again, this box is already been configured. So config, and double check that. Default gateway is that. And this is the IP address 1111, already been put in for you, /24. And we are going to add some comment in here. Go to the CLI. Oh, and by the way, this is already been powered on. So once it's green, which is good. Go to this one. That's our first configuration. So enable. I'm going to do a show run and see if accidentally I already saved it. No, it's nothing in there. Okay, that's good. So it's clean. Once it's not been configured, then we are going to look at the syntax here, and we already went through it, so I'm not going to go through that again. We just go and configure 11. Just do three blocks. We come in here, right click, we paste it in, and make sure there's no error. And we go to here, and let's just finish it off. There's that, no shot, and we give them the routing. So make sure that it's all in there. Just make sure VLAN 1, no problem. VLAN 11, no problem. IP routing, so that it will start routing, and all the interfaces of different ports that we configured is already up. So that looks good to me. Now we are going to look at, well, you can of course run a test, ping from here to here, but I'm just going to go ahead and finish that off. And we don't have to touch this one. It's just a transparent switch going there with this connecting to this ASA. You can, of course, directly connect the ASA with this switch. You can also consider that this could be your core switch, okay? Up there was the ASA going out. So this will be your high-end, Cisco high-end core switch. Go to the distribution switch, and you will have multiple VLANs, right? All right, so this is ASA, enable. Gotta click in here, no password. And we are going to look at the Cisco syntax, same thing. Config T, Cisco ASA, VLAN interface VLAN 1, we call it inside. Most secure network inside is 10.10.10 with security level 100. Outside, not secure, so it's 0. And once you see everything here is at VLAN 1. Port 1, port 2, port 3 is all VLAN 1. that means you inside, you can have that many ports. It's like a switch inside. And 00, if you define a VLAN 2, is you are making the port 0, the first port, you're making it like outside routing port, like another interface card in your ASA. So you can, of course, call this VLAN 1 and VLAN 2. VLAN 2 is already have. You can also call it VLAN 2 here. So port 1 and port 3 is VLAN 2. And then you can call it VLAN 4, VLAN 5. So you can have up to 7 different DMZ on those designs. And this is just give you a quick concept of that. Your Cisco CISS 25 class is going to cover a lot of different models of Cisco, Palo Alto, Linux, and Windows, and different firewall boxes. So let's paste it. All right, looks like no error this time. So let's take a look at it. We are going to ping it. Now, it's not going to work because we can ping because the ASA doesn't know how to get back. We don't do net or pet this time, right? Remember? So we can ping 10.10.10.1. That should be fine. You can see if you have just a quick review of concept from the 11.11, you ping outside of your network, so you have to go to your default gateway. Boom, it's already been set up. So you send it to your default gateway 192.168.11.11. Send it to here. Ask your default gateway to route it for you. And your default gateway is going to do it for you, and it start look at your destination and say, oh, 10.10.10.1, no problem. I know how to get there because I own it. Therefore, it directly reply back to you. And if you want to go to 10.10.10.10, it's going to send it here for you. And using your true IP address, 192.168.11.11, because Cisco switch below 4,000 model, they don't give you net pet function. So therefore, you have to add static route. And we already mentioned that. That's really not too much of an issue because you can have multiples, the hundreds of those VLAN, and summarize it with just one command in here. Okay. Anyways, let's continue on with that. So if I pin 10.10.10.10, it's not going to work. You can get there. You can use sniffer. You can see go there, but you're not going to see it in. I'm not going to add a sniffer. I'm going to keep this video short as possible. Now we are going to come here and add a route and run the test. First, you can type, but what I want to do is I just want to copy and paste. Different box have different syntax. It's very similar. In Windows, you will say route at, right? And in the Cisco router, you say IP route. And the ASA is route inside. It gives an interface. It's a route from your inside interface. And if you want to go here, that's the same. And Windows will put a mask in here, and Cisco don't put a mask in here. So it identify it's a class C or it's just a host, right? So this is actually a class C. If there's 0 here and this the whole thing, is the smallest number, right? Of 255.255.255, that network is 191.168.11, and something mask 0, the counterpart of the IP is the host, and 0 is the smallest host. Therefore, it identifies this as a whole class C network, right? And similarly, if it's a class B, right? The 255.255.0.0. So 0.0 is the smallest number. So it represents everything in 191.168 as a class B, meaning that .0, 191.168.0, 191.168.1, .2, .3, .4, .5, all the way to .255. It's all summarized into one single command here, and it will send it to 10.10.10.1. That's from the ASA to the student switch. Okay. So I'm going to copy it, and I'll put it in here. Okay, once you do that, then the ping should work. All right, so that proves the concept. And let's take a look at the document. Now, let me just go through this again with you because I want you to create VLAN 12, VLAN 13, if you're interested, of course. And you take a look at this, you already know how to create VLAN 12. You say you go to FA, the syntax will be interface FA 0/12. And then you're going to change the 11 to 12. And the rest is the same. And the port 13, it will be interface FA 0/13, right? And then VLAN 13, and then the rest is the same. So then you already create VLAN 12, VLAN 13. And go in here, you're going to say, hey, interface VLAN 12. And then this is 12.1. VLAN 13 is 13.1. So not that many lines, and you already know the syntax in here. So that's for the VLAN 12, VLAN 13 creations. And you don't have to add anything else. And in here, you will then drag a PC in here. You can go here, and you can just go ahead and drag a PC in here, drag another PC here, and then click the line, and you will connect here, fast Ethernet, and you're going to go to, let's say this is for VLAN 12. You connect it here, and you're going to go here, and you will connect it to the VLAN 13. Then you will connect with the IP that I gave you accordingly. This is a 12.12, 192.168.13.13. And from then on, you already can ping from 11.11 to 12.12 to 13.13. You can ping amongst those VLANs. And then in your ASA, you can summarize the route, and everything will be functioning quite smoothly. Okay. This ends our discussion of inter-VLAN routing.